We can hide this. Let's share. We can share the desktop. That's fine. We want this view. We're going to move you right here. Let's put you like this. I can expand you. I think I usually have something like this. We'll get it going. I can't remember what I usually do. I'll put you here. We can move you a little bit this way. No. A little bit indecisiveness. Hang on, guys. I'm coming. Put you here. You need to go here. Okay, so today is really just a homework session, right? So I think we finished section 1.3 last time. Okay. So what I wanted to do today, we can take time. We can honestly go over any homework assignment. Let's do like this. Let's open up this guy. Like this. Expand. Boom. That works for me. And then we're gonna go here and here. Okay. Let's see. Okay, so if there aren't any requests over any specific assignments, like if you email me, like actually now is a good time to ask those questions. Like if you email me and I didn't respond, now is a good time. Because once we leave here, my mind goes other places. I go wherever. Actually, we don't need that view. We need this view because we're not doing PowerPoint today. So yeah, so what I plan on doing today was just kind of working through assignments. So we have what? Go to 450. So we have about 40 minutes. We have about 40 minutes. So what I was gonna do was just kind of let's hop over to Pearson. I think we're in week 3, so we can work homework. We can work questions from week 1, 2, or 3. We can work from anything. Let me start with week 3 since that's the most recent thing that we've done. Unless somebody requests something else. Let me go to preview. Can this do it? Okay. Yep, that's what I want. Why does that look weird? Let's do the same thing. Okay. Okay. Let me see. We can take, let me see, if we got like 40 minutes, let's take maybe 20 minutes on this section. So I'll start the timer in just a moment. Actually, I can start it now. Let's do it right here. We'll start that one. That's fine. Hey, Google, give me a random number 1 through 21. Hey, Google, give me a random number 1 through 21.
Here's a random number, 18.
18. I didn't even open the polls. You guys are ready. I was curious. Okay. Close, though. We had a few close ones. That's pretty smooth. Let me see how we're looking. It says use the graph to find the indicated value of the function. So they want us to find f of 4, right? So if we're looking at this, when x is 4, it looks like the answer is 1, right? I'm just going to put 1. I think that was straightforward. Okay. I don't know if you guys want to open the chat. I'm going to do it again. I'm going to guess 13. I don't know why. Oh, somebody who beat me? Mr. Downs? Okay. Hey, Google, give me a random number 1 through 21.
14.
14. Close, not bad. We got 14. Nobody. We were close. Okay, let's look at question number 14. What's the time? Okay, I think we're looking good. Number 14. Use the vertical line test. Does this pass or fail the vertical line test?
Yes.
It passes, right? So is it A or B?
A.
It's A, right? It is a function. It passes, so it is a function. Awesome. Let's say open. Open. What's 11? I'm gonna go 11. Hey Google, give me a random number 1 through 21.
Here's a random number. 3.
3. I know. I think I saw it. Yeah, I see 1. Hang on. Let me see. Open. That's not the right one. Where's close? Okay. 6. Anybody got 3 this time? Oh, somebody got it last time. Okay, let's look at question number 3. So you see how quick some of these questions go, right? So if we go to question number 3, determine whether the function. What do you think? If you have x plus y equals 18, is this a function, yay or nay? How can we determine if this is a function? What are some things we could do? What does your intuition tell you? What does your first mind tell you?
Subtract x from both sides.
So, okay, so it sounds like someone suggested solve for y, right? If we solve for y, we're going to get y equals negative x plus 18. And then it should be clear that that's going to be a line with a negative slope. So if we have a line with a negative slope, is that going to be a function, yay or nay?
Yeah.
Yeah, right? Let's go yes. I'm feeling that too. Let's go here. Awesome sauce. Let's see. Let's go like this. First number I see. I think it was a 10, so I'm going to go there. Hey, Google, give me a random number 1 through 21. 7. Let's see. I chose 10. So, oh, Mr. Harris. I need to start giving out some extra credit for this. He got it right. Mr. Harris. Okay. He's the first one to get it right. Let's see. All right. I'm curious as to what you all think about this one. This one says we have x to the 7 plus y to the 9 equals 128. What did we do in the last example when we had an equation? What did we do?
Y.
We solved for y, right? Let's try to do the same thing here and let's see what happens. If we try to do the same thing here, let's see what happens. Let me start by getting a copy of the original, right? So I usually like to write on graph paper. I don't know. I just do. This is a homework session. This is section. Let's see. This is homework. This comes from week 3, section 1.3 functions. This is question number 7 from this assignment, and that comes from section 1.3, number 17 from the back, right? We want to determine if this is a function, so we have the original. Let me see. Is this a function? The original is x to the 7 plus y to the 9. Stop. Okay. Let me finish writing this. Y to the 9 equals 128. So I noticed that I'm going to go ahead and lock the session. Let's go to security and let's lock the meeting. Actually, I don't want to do a waiting room or anything. Is there anybody on the call that has not gotten attendance credit for today? Anybody in the call that has not gotten attendance credit? Mr. Blanchard. Okay. Let me go ahead. Anybody else other than Mr. Blanchard? Okay, let me go ahead and log that. So I'll mark you as late. Anybody else on the call? Okay. Awesome sauce. Okay, so I locked the meeting. And we are recording, but it's not really, to me, it's not really that big a deal. Like, to me personally, I do certain things for just record keeping and housekeeping, but at the end of the day, as long as you get your stuff submitted, you get your stuff submitted and you learn something. Like, it's not just about getting your assignment submitted, but you actually had experienced some growth or something. Hang on, give me just a moment. Oh no, redo. I think that was the end, right? I got it. Let me hop back over here. I'm going to close this out for a split second. Open it back up. It should do a lot smoother. Let's open this back up. That's better. Let's go here. Okay. So there may have been somebody kicked off, but I'm not going to worry about it. Okay. So now in the last example, we solved for y. Let's try to do the same thing here. So if we're going to solve for y, subtract the x on both sides, okay? So we'll get y to the 9 equals negative x to the 7 plus 128, right? How can we get rid of that power of 9? How can we get rid of that power of 9? Yeah, so we want to take a root, right? We want to take the nth root. So we're going to take the 9th root in this case on both sides. Notice that that 9 is odd. So because the 9 is odd, we don't have any restrictions. We don't have that whole plus or minus thing going on. Because we can take the odd root of a negative. So every x should correspond to exactly 1y. Long story short, the graph is going to look something like this, and it's going to pass the vertical line test. But it's mainly because, again, because of this 9 right here. If that were an even, then we would have a plus or minus, and the graph would actually look more like this, and it would actually fail the vertical line test. So again, the hidden part is, if this were even like square roots, when we do square root, if we do an even root, we have to introduce plus or minus, and then the plus or minus gives us this kind of shape. And it would fail the vertical line test. But because we don't have to do the plus or minus, then that's about the best explanation I can give here for why this one passes the vertical line test. Right? So every x is going to correspond to exactly 1y. So that one I was basically telling you that one. So that one should be a yes. Again, mainly because the power here is odd and it's not even. So I'm going to hit yes, and let's see what happens. Okay. I'm going to go like this. I'm going to go like this. We still got about 10 minutes left on this section. I kind of want to touch on the previous sections just to be a little bit thorough and complete. First number I see is 18, so I'm going to go for 18. Hey, Google, give me a random number 1 through 21. 13. Let's see. Anybody get that one? Doggone it. The moment I stop doing my lucky number 13, that's when it pops up. It totally likes to do that. Okay, that's all good. So let's go to question number 13. Now, we might have some repeats from today, from another day, but it's okay. Use the vertical line test. Let me see. Does this pass or fail the vertical line test?
Pass.
So is it a function, yes or no?
Yes.
Yes. Let's go yes, right? Let's see. Awesome sauce. Let's go like this, like this. Let me hit open, and let me see. Oh, that's not open. I see. I'm gonna go 19. That's the first number I saw. Hey Google, give me a random number 1 through 21.
Here's a random number, 14.
14. Okay, we got close, Mr. Downs. We did 14, so we're gonna hop to 15. Vertical line test, real quick. Does this pass or fail?
Fail.
It fails, right? That one is quick. You're gonna go. You just look at it, write the answer. You keep moving. Let's go like this. Let's go here. Let's go open. First number I saw 18. I don't know if we guessed it or not, but I'm gonna go with it. Hey Google, give me a random number 1 through 18. Sorry. Nope. Not fair. Nope. Doesn't count.
8.
Hey Google, give me a random number 1 through 21.
14.
14. Let's see. Ooh, 7, 7, 7. No winners. It's okay. 14. So we did 14. We did 15. Let's go 16. Okay, let's look at 16. Oh, see the time? That's funny. Anyway. Oh, and the eastern side. I don't know everybody. I know we're spread out over the U.S. and around the world. Answer the following questions answer the question about the following function. Do we need to go through this one, yay or nay? Does anybody request to see this one, or can we go into another one? Right, so I'm gonna skip this one actually. Let me see. I'm gonna see if I can do it quick. When x is 2, that's a 4 times 2 is 8, minus 2 is 6, minus 1 is a 5. I'm gonna say yes. If x is negative 2, let's see. That's going to be 8, 10, 9. I'm going to put 9. Awesome sauce. List a point. Negative 2 comma 9. Negative 2 comma 9. Awesome sauce. If y is -1, so that's going to be a 2. Two numbers that multiply to give me -4 and add to give me -1. Let me think about that again. That's not right. If y is -1, we add, that's a 0. So we're going to have 2x minus 1. So that's a half. So 1/2 and 0, I think, are the two answers there. 1/2, 0. I think those are right. Awesome sauce. So then the ordered pair. So then we get the first one is, come on, we get 1/2, comma, -1, and the second one is 0, comma, -1. Let's cross our fingers. That should be it. And then what's the domain of this function? It's a polynomial. It's a U-shaped graph. Y-intercept is -1. It opens up. So parabolas have a domain of the following: negative, infinity. No, that's, come on, infinity, comma to infinity. Cool beans. And then x-intercepts. So let's set y to 0. I think we just did that, but let me do it again. If we set y to 0, two numbers that multiply to give me -2 and add to give me -1, shiesta. I can't do that one fast. Hang on. I just need to factor. So I'm looking for two numbers that multiply to give me -2 and add to give me -1. If I do 1 and -2, so then we get 2x squared minus 2x plus x minus 1. We can factor out a 2x. We're left with x minus 1 plus another x minus 1. So we finish with x minus 1, 2x plus 1. I'm just trying to skip this one. I didn't want to just like leave it blank. X-intercepts. Type integers. Let me see. X-intercepts are there any commas to separate your answers. I think they want ordered pairs, right? So let's do ordered pairs. The first one is 1, 0, and the second one is -1/2, 0. I think that's it. Okay, wait. And then instead of that, let's stop. Let's not do the ordered pair. So we're gonna get rid of this. We're gonna get rid of this, that. We need that comma, and let's get rid of this guy. I think that'll be better. Awesome sauce. So we just had the wrong format. We didn't have the format that they wanted, but what we had was fine. Y-intercepts are easy. You set x is 0. You can look at it. The answer is -1. Okay. I'm not going through the details because I don't think anybody needed me to. Okay, we did that one. Took me a little bit of time, but we did it. All right. Moving and grooving. Let me see the time. Did my timer go off? No, we got 5 minutes. All right. I'm going to type open. Hey, Google, give me a random number 1 through 21. Shiesty. 2. Let's see. I don't even think I chose anything. I just typed, oh, Mr. Downs, where are you at? Congratulations. Let's look at number 2. Your senses are keen. Let's see. Determine the domain and range of the relation. Pretty straightforward, right? Domain. Do I need to explain this one, or is everybody okay with this one? Okay, just let me know if I need to explain where these answers are coming from. So the domain, that looks good. And then the range. The range is 0, no repeats. 5 and 4. 5 and 4. Is this a function, yeah or nay? Is this a function? And why did you say yes over no?
There's only each x corresponds to a different y.
Right.
No x has 2 y's.
Right. We don't, no repeating x's, right? No x corresponds to 2 y's. We don't have any repeating x's, so we should be in the clear. That was smooth. Okay, let me see. So we got about a little over 3 minutes. Let's go open. Hey, Google, give me a random number 1 through 21. 5.
Here's a random number. 12.
12. Let's see how we're looking. 2, 10, 5. Okay. 12. Okay, let's look at 12. Domain. Can anybody tell me the correct answer here or walk us through it? Anybody tell us the answer here or walk us through it?
We have to factor the bottom.
Okay, I heard factor the bottom. Okay, so let me see. This is question number 12 from this assignment. So this is number 12. Let's go back to black. And this comes from section 1.3, question 29. I just want to take this x squared minus 7x plus 12. We're going to set that equal to 0 and factor. Let's hop over to the iPad. All right. Ouch. Let me see the time. Okay. So I heard factor the bottom. So let's factor this, right? We're looking for something like this. We got x and x. Can you give me the numbers?
-3 and -4.
-3 and -4. Okay. So then we see that x equals what? 3 and 4. So we have to throw those two numbers out because they make a 0 in the denominator. So if we have to throw out 3 and 4, what should the answer be?
A.
A. I think that's pretty okay. Okay. Let's go open. And just stop me if we're moving too fast or if we need to go into more detail.
Question for the last question.
Go ahead.
So why would we put it in that form for those coordinates? How would we know to put 3 and 4 in those coordinates?
Okay. So it says the domain, right? So for a function like this, who asked the question?
Me, Ethan.
Mr. Hunt?
Yes, sir.
Should you choose to accept it? I just keep, every time I have to see you doing some kind of action something. I always go there. Anyway, let me actually get a copy of the original. So let's see, we got this f of x. We got x squared minus 7x plus 12 under x plus 5, right? This is the original. And let's actually kind of center this a little bit so it's kind of by itself. Okay. So this is the original, right? And it asks us, what's the domain of this? So in general, for a rational function, like when we have a fraction, when we have something of this form, in general, the domain is all reals except any x that makes the denominator 0. Because we cannot divide by 0. So we have to throw out any x that makes the denominator 0. So in this case, how do we determine which x makes the denominator 0? Well, what we do is set the denominator equal to 0, right? So if we set the denominator equal to 0, we have this thing, right? And then from here, we factored, right? Is the factoring okay, or do I need to go through those details?
That sounds good.
The factoring is okay? Okay. If the factoring is okay, then we get this and this. Let me see, positive, okay. So then from here, it's called the zero factor property is the next step. When things multiply to give us 0, basically we set each thing equal to 0. So we're going to say x minus 3 equals 0 or x minus 4 equals 0. Because if any of these are 0, for instance, if this is 0, 0 times anything, you know, if say this was 0, 0 times anything is 0. Say this was 0, 0 times anything is 0, right? So as long as one or the other is 0, then we get our 0. So that's the logic behind the zero factor property. So we set each one to 0 and we solve. So then when we solve, from this one we get x equals a positive 3, and this one we get x equals a positive 4, right? So what we're saying is that in the original, x cannot be equal to 3 or 4. We have to throw those two out. So if we're on the number line, again, x cannot be equal to 3 or 4. So if we're on the number line and we're trying to figure out what values of x are going to work, basically we're saying everything is going to work except the 3 and except the 4. So we want to include everything except 3 and 4. So then basically we're talking about all of these numbers going to the left, all of these numbers in the middle, and all of these numbers going to the right. And we want to exclude the 3 and we want to exclude the 4. Does that make sense? So when we write the interval notation, when we write the interval notation, basically we're trying to capture all numbers except 3 and 4, right? So then the far left is negative infinity. Let me make that infinity a little bit better. Up to 3. And then, so we want all the numbers to the left of 3, all the numbers between 3 and 4, and all the numbers to the right of 4 will work. So basically we're saying everything except 3 and 4 will work, and we combine these with the union. And that's where that came from. Hopefully that made sense.
Gotcha.
There's no worries yet. Okay. We got that one. Okay. I want to take about, if we get out at 4:50, I want to take about, let's go 7 minutes. Hey Siri, set a timer for 7 minutes.
Your timer is set for 7 minutes.
I want to hit save, or can I, is there another one? Yeah, I want to open up, let's go to 1.2. Let's preview that. We can actually, we're going to close this out, and let's preview 1.2. We're just going to go back and see if we're still proficient in 1.2. So let's shrink this window down to size and build it back up. Okay, let's see. And we got a timer going, so when the timer goes off, we're going to go back to 1.1. We got 22 questions. Let's go open. I'm going to go 13. That's fine. Hey, Google, give me a random number 1 through 22. Did you hear me? Hey, Google, give me a random number 1 through 22.
7.
7. Okay, let's see. 7. I think I opened it, right? I saw it. 13. Anybody get 7? Nobody got 7. That's okay. Let's look at 7. Okay, so 7 says, find an equation in slope-intercept form of the line that passes through this point and has the slope m. Okay. Okay. Let me get this on one page. Yeah, we can shrink that down, I guess. Let's go like this. I just want this to be on one page. And then we're going to expand it back. That looks good. And then, let's see. Okay, so let's do another header. And this is, so this is homework. Homework. This is, this comes from week 2, which is section 1.2 lines, right? Those are lies. It's not, didn't write that right. Lines. And this is question number 7 from this assignment, and that comes from section 1.2.19. Basically, find the equation of a line. Find the equation of a line with the following properties. Through this point, -7, 6, and the slope is 0. Okay? All right. What does it say? Give the equation of the line. Okay. So find the equation of a line through this point with this slope. Are there any requests on the technique? So let me kind of mention this. Whenever I work with lines, I like to have the following 3 equations ready to go. The first one that I usually like to have ready to go is a slope formula. Slope. Slope is going to be y2 minus y1 over x2 minus x1. So that's the first one I like to have ready to go. The second one after slope is point slope that I like to have. Point slope formula. And that's going to be y minus y1 equals m times x minus x1. Okay. And then the third equation that I like to have is the slope intercept. Slope intercept. Intercept. Blah, blah, blah. Formula. And that's going to be our classic y equals mx plus b. Okay. So whenever I work lines, I usually just either have them on the dome or I have them just ready to go in some form or fashion. Because I know I'm going to have to reference them. Okay. I'm partial to, I actually like to start with the slope intercept. I don't know. Student showed it to me because I used to always do point slope in this case. But my students, they did this, and I thought about it, I researched it, and I verified that what they were doing was correct. So I decided to borrow it. I felt like it was a lot more smooth than what I was doing, right? A lot easier. Okay, let's plug in what we have. So if we plug in what we have, we have that the slope is 0. That helps out tremendously. Our x, oh, well, we're there's nothing really to calculate here. The x value is -7. We don't know b, and the y value is 6. Notice this goes to 0, so that means our b is 6. So we can do this. That means we're going to have y equals 0x plus 6. But then 0 times any real number is going to be 0, right? So this is ultimately, and that's not a 6. This is ultimately just going to be y equals 6. This is a horizontal line through y equals 6. That's not what I... Awesome sauce. Like this, okay? Okay, so horizontal line through y equals 6. Let's hop back over to Pearson. Give the equation of the line. We're going to say y equals 6. Cross our fingers. Okay, do we need to graph it? So let's graph it. So this is just going to be a horizontal line, so a straight line through y equals 6 is, we can do like this point, and we can do this point. Okay, I think we're okay. Let's hit save. I'm going to check our answer. Let's see the time. We got time for one more from this section. Let's go like this. I'm going to hit open. First number I see, okay, 37 is a 10. Let's go 10. Hey Google, give me a random number 1 through 22.
Here's a random number, 17.
17. Let's see. Ooh, Mr. Harris is close, but no cigar. We got something wrong on number 7? Oh, we must not have finished. We didn't get anything wrong there. How come it gave us... Oh, because it's late. I was like, why is it giving us partial credit? Because it's late. See, it made me feel some kind of way. What did we say? 17, I think, was the answer? Let's go to number... I think it was 17. Let's go here. Wait a minute. Did we get something else wrong? We've only done one question, so... Yeah, okay. Finding the equation of a line that passes through these points. Use them to determine whether these 3 points are all on the same point. Okay, so they ask us to find the equation of the line through those 2 points, and then use that equation to verify that that 3rd point is on that line. Okay, so let's actually take some notes. Thank you. We're going to finish out this example, and I might actually let everyone go. Let's finish this one first, though. So this is question number 17. Oh, yeah, I'm coming. So this is question number 17. This comes from section 1.2, question 47. They're basically asking us, are the 3 points 3, 7, 7, 11, and -2, 2, are these points collinear? What do they spell? Is it 2 L's? Oh, they didn't use the phrase collinear. Hey Siri, spell collinear.
Collinear.
So there are 2 L's.
COLLI.
Thank you.
N
Thank you.
E.
Oh my God. She was just like ready. Okay, let's see. So this question asks us to find the equation of the line through the first 2 points. So I'm going to automatically do the following: x1, y1, x2, y2. I'm going to start with my slope formula. y2 minus y1 over x2 minus x1. If we plug in what we have, 11 minus 7 over 7 minus 3. What is that? That's 4 divided by, it looks like 4, so the slope is 1, right? So we have a slope and a point. I'm going to choose the first point. So then I'm going to hop over to this. Y equals mx plus b. Let me see, my y value is 7. My slope is 1. My x value is 3. Only thing we don't know is b. So then ultimately we get b equals 4. So then our equation of the line through the first 2 points is going to be x plus 4, right? Okay. So let's see if this works for all the points. When x is 3, y is 7, that checks out. Oh, wait a minute. We made a mistake somewhere. Let's back up. That's a 4. That's a 4. Yeah, we made a mistake. 11 minus 7. When y is 7, I think the 1 is good. 7 minus 3 is 4. That's 4. That's a 1. 7 minus 3 is 4. We get 3 plus 4 is 7. Okay, I don't know what I'm looking at. 7 plus 4 is 11, so we're good to go there. And I think negative 2 plus 4 is indeed 2, right? So they all check out. Okay. So, I think I was just adding wrong. I kept seeing 3 for some reason. Slope-intercept form, so that's y equals mx plus b. So we're going to say y equals x plus 4. Cross our fingers. We're good to go. Okay. Did anybody have any burning questions they'd like to ask before we part ways? Any burning questions? If there aren't any burning questions, we are going to be here on Monday. So unfortunately, we don't get to take the holiday as far as this class is concerned. But fortunately, we're actually going to be done with the semester before Thanksgiving. So that means I think we get an extended like Christmas break to give us more time to like dodge COVID and stuff and to survive. Because I'm totally nervous about the wintertime. But, you know, that's life, and I think we'll be fine in the long run. Yeah, I'm going to just kind of let everybody go if there aren't any burning questions. Okay, guys, have a great weekend, and I will see you all on Monday. Deuces up, 8-time down. Peace. Take care.
Thank you.
Professor.
Thank you.
Have a good weekend.
Thank you,
Come
Professor.
all around.
Have a good weekend.
Guys are so funny. All right, let me share this. I'm going to send this to, send a copy so everybody can pull it for later if they need it. Let's go here. Let's go here. That's this one. Here. Send it right there. Share. Okay. Let's stop this.